All right, we're going to continue talking about solving radicals, but we're going to do a little bit of conversion of fractional exponents and also converting radicals to fractional exponents. I'm going to give you a moment to write down these three notes. This is what we're going to be doing today. You will have a few opportunities to practice solving like we did yesterday. But this is some notes that we definitely need to have moving forward on today's lesson. I'll try to explain what each of these are, but for the moment, I just need you guys to begin copying this down. So the first part of our notes talks about any negative number in the exponent. What a negative number means in the exponent is that it belongs on the other side of the numerator / denominator. So this does not actually have a denominator, so we're talking about a numerator here. So when I have a to a negative n power, that is translated to 1 over a to a positive n. If it would have been in the denominator, it would have been moved to the numerator. So if we had one that looked like this, 1 over a to the negative n, that would be equal to a to the n in the numerator. So these both go hand in hand. Now if we have a negative sign, negative value, exponent wrapped around a parentheses, what that means is everything inside of the parentheses is going to change side. So as you can see here, we have a to the n in the numerator. Well, this negative 1 is going to move it to the denominator. And we have a to the m in the denominator, and this negative 1 is going to force it into the numerator. So we will see some negative exponents. We're kind of getting a little bit ahead of ourselves on this, but I'm okay with that because it kind of goes a little bit with what we're doing today. And what we're really doing today is this little note that we have here. This is the conversion of a radical into an exponent, a fractional exponent. This kind of looks a little funny, but this is actually a to the n over m power. What we need to know about this is whatever is in the index is in the denominator of the fractional exponent. And whatever is in the power attached to the radicand is in the numerator of the exponent. Now this number is always there, so if it doesn't have an exponent, it's an understood 1. So keep that in mind as we work through all of these. So let's put this one to practice. As you can see, what it says is write the expression in an exponential form. So we're trying to find x to a power. That's the exponential form. So what we have in this case is a radical, which means this exponent is going to have a fraction. And on this fraction, whatever is in the index belongs in the denominator of our exponent, and whatever is in the power belongs in the numerator. So this would look like this. Just to make it look right, this would be all the same color here. X to the 2 over 7 power. And we can work this the other way as well. This one we're going to write the expression in a radical form. So we're going to put this into a radical form. Well, this is a fractional exponent. This is x to the 2/5 power. This would look like this if you were That graphic looks a little bit off, but that's what it would actually look like. Well, now it's just gone. There it is. So what we have is the variable going into the bottom here, and whatever is the denominator is the index, which goes here, and whatever is the numerator is the power attached to the variable, which goes there. So this answer, it's not or, I'm just going to rewrite this where it looks a little better, is the fifth root of x squared. All right, on this is again where we're kind of working a little bit of ahead, but I'm okay with that. We're talking about fractional exponents, so why not talk about on the negative front? Well, on the negative front, the main thing we need to recognize is that this stuff is all on the wrong side of the numerator or denominator. And of course, this doesn't truly have a denominator that we see, so it's an understood 1. So what we're going to do is we're going to take all of this value and move it to a denominator. So we're going to go one step at a time on this, and we're going to move the 3x to the bottom and the 3/2 power to the bottom as well. Now when we do this, we get to drop that negative sign. When you have a negative exponent, that's essentially what it's telling you to do, is to move it to the other side of the division or the radical sign. So when we immediately see this, what we can do is mark out these two answers, because those two answers still have our values in the numerator, which is not where they will be. Now, the numerator is going to stay 1. We've got to change our denominator into a radical expression. Well, the base, that's called a base, by the way. The base is going to be our radicand. And since this has a denominator of 2, our index is 2. And since this has a power of 3, our equation has a power of 3. And we do need to put this in parentheses. If I leave off the parentheses, the only thing that is getting cubed would be the x, but I want the 3 and the x to get cubed, so our correct answer would be this one. The other thing you can do, if you graph these things, y1 equals our equation, make sure you put the parentheses, and your y2 equals what we just had there, and you would want to use the fraction mode in your calculator. Remember, that's alpha F1, the very top left button of your calculator. Those two should have identical tables because they are identical numbers, because all we've done is converted them from one type of expression to the next. So I suggest that you take care of that negative exponent and then worry about the fraction. So I picked this one because I feel like it looked very difficult. So let's see how difficult it actually is. Well, first thing I'm going to do, I do not like these negative exponents. I like to take care of them first. There's not a rule that says they have to be taken care of first, but I personally like to. What that means is to change anything that has a negative exponent to the opposite side. I want you to understand, I'm not flipping this equation. It's just now we are going to have a denominator of 1, so we don't have to write it. But this gets moved to the top to join the 1, so therefore it's this. So this will not be in a fraction form because we have no reason to convert it back. So these two answers are incorrect. Now once we've done this, now it's just time to convert into a radical form. So this is going to be a square root sign. Our index in its parentheses goes here. And again, the value that's the denominator is the index, which in this case is 3. And the power, which is the numerator, is going to be attached to our value there. So this answer is also wrong. This answer would be correct. And again, just like on the last one, you could have graphed y1, y2. The table should match identically. All right, we just got two more examples here. Now, we have actually dealt with this yesterday. We've dealt with our warm-ups the last 2 days. When we have a power to a power, we multiply these. This one it doesn't say to solve, it says to simplify these. You could put this in your calculator, it's going to give you a number, but it's not asking us for the number, it's asking us to simplify. So in radical form, by the way, we're going to simplify this in radical form. So when we have a power to a power, what we have to do is multiply their exponents. So this is going to be 10 to the 3/4 power. Once we have that, we're going to convert it to a radical. And just like we've been doing, the base number is the base number. So in this case, that was 10. The index is the denominator. So this is going to be 4. And the numerator is the power attached to our value 10. You could technically put a parentheses, but it's unnecessary. So this would be the simplified radical form for this particular question. All right, this one's going to be our last example. This is going to be our last example. And this one, you do need to be careful because a lot of times what we want to do is just address the variable, but this one has the 81 and the variable in the parentheses. So there's two methods that we could do this. We can take the 81 to the 3/4, we can split these up. 81 to the 3/4 power, and we can take the x to the 4th times 3/4. Because remember, we're multiplying their powers together, and the 81 technically has a power of 1 here. So if we're taking a look at this, the 81 in radical form would be a 4th root 81 to a 3rd power. So this right side, 4 times 3/4, the 4s are going to cancel. So this is just going to be x to the 3rd power. Now we can actually do this a number of ways. You could put this directly into your calculator, and it's going to give you 27. There's another way you could do this. You could find the 4th root of 81. You could find the 4th root of 81, which exists, that's 3, and then take it to the 3rd power. Or you could cube 81 and then take the 4th root of that. So I'm halfway done with this part right here. Or let's just put in our calculator. We put in our calculator and we get 27. I want to finish mine out though, because it's the 4th root of 81 is 3. Because what a 4th root is the square root of the square root. So the square root of 81 is 9, and the square root of that is 3. So anytime you are dealing with a 4th root, it's the square root of the square root. So in this case, we end up with 27 x to the 3rd power. And once again, we can go to our y1 equals and type in our original equation, and we can go to our y2 equals, type in our result, and they should have identical graphs and tables. All right, you have a Delta Math posted on this. I also want you to notice I've created a couple of homework assignments for this week. One is a Kahoot. One is a Kami assignment. So those can be done on your own time. Neither one of them are incredibly long. You should be able to finish those quickly. So good luck.